Welcome to the Dell Technologies Power to Protect podcast, where we discuss innovation and thought leadership in the data protection space.
Hello and welcome to the Dell Technologies Data Protection Power to Protect podcast. I am Jenna Spazio from Solutions Marketing, and today I am sitting with my colleague Rob Mossi. Rob, would you please introduce yourself to our audience and tell them what we are going to be discussing?
Hi, everybody. Yep, my name is Rob Mossi. I'm a product marketing consultant in the data protection product marketing team. I'm representing the Power Protect Data Manager product. On today's podcast, we're going to talk about the rise of cloud-native computing, provide an overview of containers, and specifically get into Kubernetes. We're going to also talk about how a Power Protect Data Manager can help solve some of the growing customer problems around containers.
That's fantastic. This is a really hot topic, and thank you, Rob. Why don't we just get right into this and introduce our guests? Nivas, are you there?
Yeah, I'm here, and thank you, Jen, and thanks, Rob. So really excited to be part of this podcast. So I'm a product owner in Dell Technologies. So I own the Kubernetes and cloud-native data protection capabilities as part of the data protection division software and SaaS team. So I work with our customers, field, marketing, engineering, and the whole ecosystem to grow these huge innovation engines in Power Protect.
That's fantastic. So the industry is abuzz around containers and Kubernetes, and we really want to highlight how data protection plays into this space. But before we get into that, Nivas, can you please give us a quick summary from your point of view? What are containers?
Yeah. So Jen, if you look at it, like the history of computer science, right? So from programming languages to object-oriented programming to the development of virtualization and cloud infrastructure, the history of computer science is a history of development of abstractions that hide complexity and empower you to build ever more sophisticated applications. So containers and container orchestration APIs like Docker and Kubernetes have proven to be an important abstraction that radically simplifies the development of reliable, scalable, distributed systems. So containers provide a very simple way for development and operations team to consistently execute and increase productivity. The surge in popularity of containers has skyrocketed since release to the open source community half a decade ago. Open source container orchestration tools such as Kubernetes allow IT teams to break apart monolithic applications into smaller, distinct microservices and reliably run applications between computing platforms. Adopting containers enables applications to run virtually anywhere. So it creates a predictable dev test environment and significantly increasing productivity and agility. One huge benefit of microservices and containers is that the large software organization can be organized into smaller working groups, also called 1 to 2 pizza teams, who can work independently, and they are decoupled from each other. They manage their own release to production, so the teams spend less time debugging and diagnosing differences in environments, and they spend more time shipping new functionality for users.
That's great, Nivas. Thank you so much. So it makes perfect sense that cloud-native containers are gaining traction. But let's specifically address Kubernetes. What is all the fuss? What's the buzz around Kubernetes specifically?
So containers seem to be the answer to the customer problem of how to continually run applications across multiple computing environments. So Kubernetes specifically is an open source platform that provides orchestration of containerized applications. So if you look at it, right, and the relationship of Kubernetes and containers, such as Docker, it is very analogous to that of vCenter and vSphere or ESXi hosts in a virtualized environment. So Kubernetes uses declarative configurations which represent the desired state that developers define, and it continually monitors the environment to ensure that the running instance matches the declarative config. So for example, if you define that you need to have 3 copies of your application or replicas to be running at any given time, and say due to some failure, one of them goes down. So Kubernetes will continue to monitor the environment, and it will try to ensure that there are always 3 copies active by automatically scheduling a new instance. And hence it prevents against any failures. And also scaling is very easy. So all you need to do is change the number of replicas that you have defined in the configuration, and Kubernetes will do this automatically for you. So the benefit of Kubernetes is that it is ideal for hosting distributed cloud-native applications with requirements for flexible demand and or rollback of applications.
So it appears that Kubernetes are really an enabler, from the abstraction aspect all the way through the scaling, how it's an enabler for digital transformation. Does that include the move to containers and specifically Kubernetes in this transformational time?
So if you look at most enterprise IT are focused on digital transformation projects, and the outcome, the intent of these projects is to create new or modify existing business processes, culture, and customer experiences to meet changing business and market requirements. We see this all around us. For example, my popular coffee store, it allows me to order my latte through an app, and this automatically sends this to the closest location, and they have my latte ready at the pickup counter without having me to wait for 30 to 45 minutes during rush hours. So there's a lot of complexity and coordination to deliver this experience. And this is possible due to the move towards microservices and cloud-native architectures to manage the agility and rapid delivery timelines. So Kubernetes and containers are fast emerging as the key platform to enable this. So as IT and development teams modernize, Kubernetes and containers are becoming part of the development fabric.
All right, so we all understand coffee, right? That's pretty much what gets us going on a daily basis. But let's talk about some other examples. How else are Kubernetes being used just in everyday life? I mean, there's some great examples of some very creative and some very behind the scenes use of Kubernetes.
So one of the most popular examples is that of Pokemon Go. So, it's a very popular game. So when the game was originally launched, the traffic surged so much that it was more than 50 times the original estimate, and the application could no longer keep up with the surge in demand. So later on, the developers, they re-architected the application to be containerized and deployed it on a Kubernetes platform to be able to scale with the growing, user demand. And if you look at enterprise, the enterprise adopters of Kubernetes, such as Goldman Sachs, Nordstrom, Comcast, just to name a few, they rely on Kubernetes to help transform internal applications, as well as make their products more dynamic, scalable, and portable.
So let's switch gears a little bit, Rob and Nivas. It sounds like Kubernetes adoption is helping to solve some agility challenges for development teams, but what are their challenges?
So the cloud monitoring company Datadog recently surveyed that container users to discover that over 45% were using Kubernetes, and that represents a 20% increase over 2018.
And with that, popularity becomes the challenges that I'm asking more information about. Like in a report from early 2019, I believe I read that an analyst firm identified that security monitoring, data management, and network were areas that needed to be addressed when deploying containers, and that, there's a lot of cloud-native applications that require a high degree of infrastructure automation, specialized operation skills that are not commonly found in enterprise IT organizations. So we know that with innovation, change can be a challenge. So for the sake of this discussion, I wanted to focus on data management, that challenge in particular, and how we as a data protection entity are solving those challenges.
So Jen, when you look at a typical application from 90s on, right? So it is divided into 3 layers, what we call the model, view, controller paradigm. So the model is the backend transactional database, something like Oracle, and it's used for robust transactions from everything from credit card processing to billing and ERP workflows. And the view is the front end, which is the layer that interacts with the user. in the 90s who was, using browsing through a static browser on a PC, and the control is the middle layer that navigates between these two layers. What we see now, of course, with the development of smartphones and and with huge volumes of data, we have seen that in the new containerized applications, the focus is on delivering a compelling end-to-end user experience. And this requires a significant amount of data. And all this data is stored in middle tier in scale-out databases. And all these are brand new, such as MySQL, Postgres, Mongo, Cassandra, etc. So these databases are hosted in containers, and they all need to be protected as this data represents the application state. So let me give you an example, right? So I subscribe to a popular video streaming service without naming any names. And since they have so many titles, they have like over 1 million titles, I mostly rely on their recommendation engine, which is based on, my past viewing history and, what I viewed, what I liked. And what I was actually binge watching a lot. So I decided that I need to unsubscribe. I need to take a break. So I unsubscribed from the service for a few months. And when I restarted the service, they had deleted all my viewing history. And as a result, the platform could no longer provide me with the best recommendations as they no longer had access to my viewing history. So even the best algorithms in the world, they rely on information to deliver the best user experience. So while the Kubernetes infrastructure is focused on application resiliency and preventing failures, here it's assumed that the application is stateless. And what we are seeing is a huge rise in stateful applications. And unfortunately, this problem is not seen as a major challenge yet, but we anticipate that this will be a growing challenge as the platform gains adoption. So according to Newslack, a recent survey at KubeCon in October 2019, which comprised of 380 respondents, over 55% are deploying database workloads in Kubernetes in containers. That represents a 23% increase over 2018. So additionally, there are various IT teams that are specialized. For example, there's a team responsible for data science. There's probably another team doing user experience projects, team responsible for infrastructure and backup, another managing virtualized environments, separate team managing Kubernetes, DevOps, etc. So when we talked earlier about microservices, right, we talked about decoupling the dev teams, right? So they are independent of each other. So same concept can be extended to IT operations, and it's extremely important to allow these teams to work independently, to allow for the scale and agility of the operations instead of adding more coordination and meetings.
That's great. You bring up a really good point about KubeCon back in October of 2019. And I actually had the luxury of being able to attend KubeCon as well. And data protection was definitely on the mind of the attendees. I attended a session specifically around data protection for Kubernetes, and the room was absolutely packed. In fact, overflowing, standing room only. So the topic is extremely relevant, which brings us to why we're here today. So a bit of a segue. I'd love to talk to you a little bit about PowerProtect Data Manager and how it was designed to help address both data protection and data management problems for our customers. So really kind of enabling some of that IT transformation. So not only does PowerProtect Data Manager protect some of those traditional transactional workloads that you had mentioned earlier, those stateful workloads like SQL, Oracle, in addition to VMware VMs and file system data, but it also now protects Kubernetes and Kubernetes containers, all directly to our PowerProtect DD and or a data domain protection storage. So Nivas, can you just explain a little bit about how PowerProtect Data Manager can assist with agility and IT transformation?
Yeah, as you rightly said, Rob, PowerProtect is designed from the ground up to serve as a single platform for all the IT workloads, from mission-critical bare metal applications, virtualized applications. And since 19.3, which is like last December, it also protects Kubernetes environments. So this is the first and only solution that provides enterprise-grade protection for Kubernetes. So another key feature of the platform is that it provides a unique user experience to to the various administrators, the ones that we talked about earlier.